everyone. I'm Devesh Shrestha and I'm presenting my research on understanding and predicting the consumption of users of the appliances. Firstly, understanding the data, whereas X1 and X2 represent temperature and humidity in living room, whereas X3 and X4 represent temperature and humidity in office room, whereas X5 represents pressure and Y represent energy consumption. Our scatter plots reveal interesting relationships. The living room temperature shows approximate straight line trends with energy consumption scattered across all values. More interestingly, the office temperature shows a concentrated range between 35 to 45 degrees Celsius with a strong downward slope. For humidity, both rooms shows gradual decrease in energy use as humidity increases, with the office showing more controlled patterns between 18 to 24 degrees Celsius. Looking at our histogram distribution, the living temperature isn't uniform across its range, showing multiple peaks around 15,000. The office temperature displays a dominant bell curve between 40 to 45 degrees Celsius. For humidity, the living room peaks at 20%, while the office maintains a symmetric distribution between 20 to 22%, whereas energy consumption stays remarkably consistent between 750 to 760. Our analysis shows extreme variability in the living room temperature with a standard deviation of 5,406.67, while energy consumption maintains a tight range of 732 to 770. All variables negatively correlate with energy consumption, with office temperature showing the strongest correlation at -0.234. We normalized all variables to a 0 to 1 scale for fair comparison and a sample size of 450. After transformation, office measurements showed higher central tendencies, while living room variable displayed lower, more spread out value. The energy consumption remained centrally positioned at 0.61 to 0.62. The histogram analysis reveals consistent temperature variations in the living room, a controlled bell curve distribution for office temperature, right skewed humidity patterns in the living room, and a more regulated normal distribution for office humidity. The office variable exhibit higher frequency counts in their peak regions compared to the more variable living room variables, and the energy consumption follows a normal curve with symmetric spread, suggesting stable energy uses. And we used four build models. Firstly, WAM, weighted arithmetic mean. Secondly, weighted power mean with P equals to zero point 0.5 and 0 and 2. And lastly, OWA, ordered weight averaging. And comparing the result, WPM with P equals to 2 performed best with lowest RMSE, where the result is 0.2393, whereas WPM P equals to zero point 0.5 showed strongest correlation with result of minus 0.2876, and OWA provided second best error measurement, whereas lastly WAM served as our baseline model. And talking about the prediction setup and input analysis, the two rooms showed a temperature around 19 degrees Celsius, whereas the humidity levels are hovering around 43%, where testing our model revealed significant challenges. The actual values is 60 units, predicted is 732 units. This resulted in a 122% relative error, indicating substantial overestimation. Office temperature emerged as a dominant factor, accounting for 70.46% of the model weight. Humidity showed moderate influence at about 21% combined. Living room temperature had minimal impact at 7.81. And lastly, the recommendation. Based on our finding, we recommend prioritizing office temperature control, maintaining moderate humidity levels, implementing continuous monitoring, and lastly, regular system calibration and updates. Thank you.